plot you are looking at shows constant velocity, and you can calculate the velocity by finding the slope. Since the slope doesn't change, you can use any 2 points on the line to find the velocity. When you have a plot with increasing velocity, you need to use a different approach. This presentation outlines the method for finding the velocity of an object whose velocity is never constant. Here is the displacement versus time plot for an object whose velocity increases the entire time that it is studied. The graphic below shows the position of a runner every second. Notice that the distance the runner covers during a 1 second period increases with time. If the runner was slowing down, the spacing would be reversed and the distances would decrease. Let's take another look at the animation we saw at the beginning of the presentation. When the slope of a displacement versus time plot doesn't change, we can find the velocity using any 2 points on the line. When the slope, and therefore the velocity, changes the whole time, we can only find the velocity at a particular point in time. The velocity of an object at a particular point in time is called the instantaneous velocity. Speedometers give drivers their instantaneous velocity. What is the velocity of the object at 6 seconds? If we wanted to find the velocity of the object at 6 seconds, we would have to draw a tangent line to the plot at that moment. Before we do that, we need to draw a dotted line up from the time we are interested in, which is 6 seconds. We then draw a tangent line where the dotted line hits the plot. The tangent line should hit the plot at a single point. Once we have the tangent line, we pick 2 points on the tangent line so that we can calculate the velocity. The velocity is 0.4 meters per second. That's about a third of the speed of a typical walk. This is the end of my presentation on finding instantaneous velocity.